Sure. You're welcome. You're funny. All good. Let me do this. Hold on. Where's my keys? This is very natural right here, just like this. Yep, that'll work. Here you go. You're welcome. Okay. Whew. That just made me dizzy. Okay. Let's do this. Copy. New. I forgot which one's paste. Is it this one? Ooh. 3. Okay. There we go. I'm sure that you guys are wondering if lab work or no lab work. I'm still tallying up. I had to message some people that weren't here, so that is still to be determined at this point in time. Don't worry, I did not forget about you. And we should probably do this as well. I'm pretty sure this is it. Ooh. I always do this. So again, the same 4 questions that you guys should be asking yourself after the first exam of could I have done something different? Do I need to adjust my study habits? Is there some things that you guys are doing that you guys feel like, man, I feel like I'm doing it, but it's just not paying off? Is there something like that that's going on that I can probably help with? Because ultimately, I just want you to be successful, right? Even though you guys might not think that I'm trying to do that for you. But that is essentially my goal. You guys might as well come on up and grab your exam. All right. Yes, I saw that. Thank you. Any questions on the exam? Yeah. And just so you guys know, if you guys look at those, so whatever I mark off, that is the correct answer, right? So if you are going through it and you're like, wait a minute, I still got the same answer, I'm pretty sure I'm right. I don't have a problem with saying, let's look at it, and then saying, you're right, and then give you guys credit for it. I don't have a problem with that whatsoever, okay?
So you crossed off both of these? Is that like, did you mean to cross one off or?
Both.
Both, so 20 and 21.
Yeah, wherever those two are. Yeah, 20 and 21. So it is. So 20 is supposed to be
B.
B, and then C.
All right, thank you.
Okay. Yeah. Let's see.
Question 20.
Mm-hmm.
It was factoring 9x squared plus 25.
That's not factorable.
It's not?
Nope. Because it's not difference, not subtraction. So that's why it's B. There you
I
go.
didn't even pick up on that.
It's all good. That's why I'm here.
I just assumed it was
That's what a lot of people, that's a mistake that a lot of people make, so makes sense, absolutely. Any other questions? The battle of lab work or no lab work is pretty skewed. It is very funny to me, only because the 10 a.m. classes want to keep it, the 3 p.m. class wants to get rid of it, like by a landslide. And I was thinking that you guys, in terms of intermediate algebra, would be landslide the other direction, number one. Number two, at least somewhere close in the middle where it's like, okay, half of us don't want it, half of us do. That's what's happening in college algebra for you guys. It's very much a landslide. So let me take a couple of more looks under my Canvas inbox, and then I'll let you guys know on Wednesday. But I would say to you right now, most likely, it will be a yes to keep it. Okay? So, again, I urge you guys to do what I've asked you guys to do in terms of do the work, all right? So most likely, besides the optional lab work, most likely your lab work is only going to have 2 or 3, maybe at most 5 of the same exact what we know. Is that fair? It's not going to be like, if there's 10 problems, there shouldn't be 10 what we knows. Right? So if you want to do the problems and you go, okay, it seems like I'm doing the same thing over and over and over, chances are the what we know is going to be exactly the same. So for example, this exam here, parentheses raised to a power, right? We'd use the exponent rules. The what we know for all of those problems are probably going to be the same, right? If we're factoring, no matter if it's 2 terms, 3 terms, 4 terms, most likely the what we know for that is all the same. All right? And if it's quadratic equation, what we know is going to be about the same, right? So I just wanted to throw that out to you guys so that maybe that will help you guys. And if it means that you got to throw that in the chat and then bring that back into the notes, do that, because that will probably help you. But it means that you guys got to go back in the notes, right? And sometimes you don't have everything written down. I understand that as well. So don't forget that you guys can go into Canvas, right? And if I go into the weeks here, like if I went to week 5, don't forget that you have these live lectures, right? That the PDF is there. You don't necessarily have to go through the video again. It will probably help, but at least you know that whatever I wrote down for notes is already there. So you can always go back into it, all right? And also as a reminder, if I go to this week's notes, week 8, those notes are already there as well. So if you wanted to write that down, now, am I going to go in the same exact order? Probably not. I'll probably use the same examples. And the only reason why I'm probably not going to go in the same order is only because, not in terms of like, I'm going to do section 1 last and the section 2 first and section 5, next. It's not that type of out of order. It's still going to be the same exact notes, except I might condense some of the things and feel, for me, I feel like, okay, this is a little bit too long, where I'm going to condense it, but you're going to still see pretty much the same things, okay? So if the lab work was to stay live, that's what I would strongly suggest to you guys to kind of help you guys get to the better grade, okay? And I would strongly urge you. In fact, last week, I wish I could go, but there was a speaker that came from a different college that was talking exactly about AI and cheating and stuff like that. So I asked the person who ran it, and this past Friday, how did it go? What did you think? And they said, essentially repeating the words I said as well in terms of AI is going to be your future. And basically the things that he said, some of the professors need to hear in terms of you need to guide your students on how to use AI, right? Figuring out where that fine line is of cheating versus not cheating, okay? And that's why I'm trying to help you. But I'm also doing as they would say, kill 2 birds with 1 stone, right? In terms of trying to get you guys to use it, but yet reflect it back into the notes. So it forces you guys to go back in your notes. And I'm forcing you guys to rewrite those what we know, right? So you're going to, yes, if there's 10 problems, you're going to write the what we know 10 times. If it's like 10 of the same exact problems, let's say if I gave you a lab work that was all factoring, you would write that 10 times because I want you to be able to rewrite that so that it's easier for you to recall and retain that information, okay? So that's what I'm trying to do. I know that sometimes for you guys, you don't realize what I'm trying to do in terms of getting you guys to be successful. I understand that. But I also understand if you do it, trust me, in a year or so, you're going to be like, that MFR was right. I promise you that, okay? Because one of my past students who is working in the library as a peer tutor right now, he actually came to me, he said, there's a lot of students that had you that decide not to have you anymore because of the lab work, but they come in all the time and saying, I wish I had Chan again. I wasn't trying to pull that out of him. That's something that he's saying to me. And the cool part about what he's doing is that he wants to be a math professor, right? And I told him that he can't always have me. He needs to have other professors and take the positive stuff that I do, use it, take the positive things that they do, use it, and just kind of throw away things that you don't find useful. But in 5-10 years, he might find it useful. He might be like, oh my goodness, that professor did this. Now I disagree with Chan on this, but I agree with what they're doing on this. That's fine. Because I want him to become the best professor that he can be as well. So it doesn't have to be my way. And I'm not saying that my way is the best way. I'm just saying this is what I feel that is the best thing for you guys, the best I can. Okay? All right. So there's no other questions. You guys ready to start? All right. So we're going to start off by talking about restrictions. Well, let me actually, here, hold on, before I write this. Well, so we're going to be basically talking about rational expressions. So rational expressions. So yes, we're going to get into rational equations as well, but we're going to first talk about the expressions first because the expressions doesn't have an equal sign where the equations have an equal sign. So rational expressions, what are they? The word rational just means fractions. Okay? The word rational means fractions. So that means I have a over b. Fractions have an issue. And you guys found that out in exam 1. Do you guys remember what that issue was with fractions? It came up during slope. When I have a horizontal line, what kind of slope do I have? So think about it, rise over run. If I go from one point to another, how much did I rise? 0. And I ran some, right? So it'd be 0 over some number. So what was the slope here? If we put 0 divided by any number, what do we get on the calculator? 0. How about a vertical line? Do rise over run. We rise something. How much do we run? 0. So it's some number over 0. So if I type some number divided by 0 on our calculator, what do we get? Undefined. Right? We get an error. Make sense? So anytime the denominator is 0, our fraction's undefined. What does undefined mean? It means it never existed. Doesn't exist. Right? So the slope of a vertical line does not exist. Okay? That's why they say there's no slope, because it doesn't exist. So in a fraction, the b cannot equal to 0, or better yet, the denominator cannot equal to 0, because if it was to equal 0, then the fraction would be undefined. That means the fraction didn't exist. Therefore, that expression never was there. Right? So this is what is going to create restrictions. So this would create restrictions. So let's say, for example, we have this expression, this fraction. In a fraction, can the numerator be 0? Can the top be 0? Yes, because we can do 0 divided by a number. Make sense? So in a fraction, we can have a 0 in the numerator. In the top, it can be 0. It's the denominator that cannot be 0. Okay? So in this case, in this expression here, what would make this denominator 0? If x was what? If x was 1, then that denominator would be 0, right? Does that make sense? Okay? So what do we do? Here's all we do. Okay, that makes a circle or ellipse. We say that that denominator cannot equal to 0. So we see that x cannot be 1. We solve it the same way as if we had an equation, right? Add 1 to both sides, and then we got x by itself, right? Because if x was equal to 1, then that denominator would be 0, right? If x was equal to 1, 1 minus 1 is 0. Got it? Okay? So there's two things. One, they're going to ask for restrictions. The restriction is just x cannot equal to 1. That is a restriction. We all have restrictions, right? Now, it also is going to ask about domain. What's domain? All the possible x values, right? Okay. So what other x values can I use? So domain is what am I allowed? Restriction is what can I not have? Right? So domain would be what? If x cannot equal to 1, what's my domain? So here is going to be two things that you're going to see. One is going to be what you're going to see this class, and then one is going to be what you're going to see next semester, okay? Because we got to raise the game. So for right now, all you're going to see is this. For all x, such that vertical line is just such that x is all real, comma, x cannot equal to 1. That is what you're going to see mostly this semester. And I'll show you guys what you're going to actually see next semester for your domain. So this is called a set notation. And I'm going to talk about the interval notation. So the interval notation, if I was to look at a number line, we have an open circle at 1, because it can't be 1. Then I'm going to have an arrow pointed to the right, arrow pointed to the left. So when it says x is all reals, x cannot equal to 1, this is what is actually showing. That means anything from negative infinity to 1, but not including 1, we can use. We can use anything that's not including 1 all the way to positive infinity, meaning we can use any other number except for 1. Okay? So this arrow right here, if I was to do an interval notation, would be parentheses, negative infinity, comma, 1, parentheses. Union with 1, comma, infinity. So interval notation-wise, that is what it would show. So I'm just looking at the left arrow. That's the left one. The right arrow is what this is as well. The reason why we use parentheses is because we don't include it or we can't touch it. We can't touch negative infinity nor positive infinity. That's why those are always parentheses. I'm not going to include 1. That's why I also use parentheses. Again, you're going to see that next semester. You're not going to see it now. Okay? Are we okay there? Questions? The U means including, and. So it's this and this. Okay? Awesome. And it's and basically the symbol is called union. And union would be this and this. Where upside down U would be called the intersect, which you will also learn next semester as well. Okay? Any questions there? So whenever we see a rational expression, our concern is when there's x in the denominator. That's our main concern. Okay? So if I was to rewrite this, oh boy, that's not going to work. But let's say I put it over 3. Is there any x values that I can put in to make that denominator 0? No, because 3 is a 3. I can't make it a 0 unless I multiply by something, 0, or I add or subtract something to it, right? So same thing as above. I take the, I take that denominator, and I said 3 cannot equal to 0. You're like, yeah, you're right. 3 does not equal to 0. That is true, right? So therefore, do I have any restrictions? No, no restrictions. So my domain is going to be written as that. And in interval notation, since it's all reals, that means going from negative infinity to positive infinity. Are we okay there? Does that make sense? We're good? Okay. Notice that we haven't done anything with the numerator, right? Done nothing with the top. Why? Because we really, the top doesn't really matter in terms of restrictions. Restrictions are really about the denominator, right? It's kind of like when we're dating someone and we're wondering if we should be with them, we should be focusing on their foundation, right? What makes them tick, right? We want to see if they were raised properly. We're wondering if they can treat us well, right? We want to know what their foundation is. Okay, what if we had this? What do we do with that? How do I go about doing that? So the comment was, we find the x values that would make that denominator 0. Okay, so how do we go about doing that? So we're saying that the denominator, x squared minus 2x minus 15, cannot equal to 0. Awesome. Does this look familiar? It's almost like we didn't even leave exam 2 yet, have we? Because we haven't. this is the AC method. So let me ask you guys by the raise of hands, how many of you guys feel like that you guys can earn your $1,000 back and you know the AC method like the back of your hand? Oh boy. it's like you're a princess waving to the crowd. All right. So you're saying that I shouldn't tell you guys the easy way yet. Because this is the AC method. Right? Because it's trinomial. So why don't you guys go ahead and do the AC method and see what you guys come up with. Go. This would tell me if you guys are getting the AC method down or not. Gesundheit. And I noticed that most people at home did not even raise their hand about the AC method. John says he's got it. All right. A times C would be negative 15. B is negative 2. So you got to find, because it's about the coefficient of x squared, which is 1 when there's no number. Why'd you pick those two numbers? Do they add up to negative 2? Okay. A times C is negative 15. B is negative 2. It looks like she's got it down. Mm-hmm. You're trying to find the two numbers that multiply together to give you negative 15, added together to give you negative 2. Just don't forget to put x there. That's all. But you got it. Okay, what do you do with those two numbers? You replace it. Yep, you split the middle term. You split the middle term. You split that one into 2. And then write that. X, and then minus 15. Minus 15, and then draw the line down the center. That gives you positive 2, not negative 2. That does, good. Okay. All right. Some of us have it down. If you guys think while I was joking about the necessity of getting this down, I hope that you guys aren't thinking that I was joking, because I'm not. So once we find these two numbers, it splits the middle term. Oh, that's right. You missed this whole thing. So that means that x cannot be 5 and x cannot be negative 3. Because we would set each factor equal to 0. Oh, not equal to 0, I should say. So what we're supposed to do, just so you guys know, we would say that x minus 5 cannot equal to 0. X plus 3 cannot equal to 0. And that's where we get these two answers here. So restriction-wise, it would just say x cannot be negative 3 and 5. Are we okay?
I just have a question on why the x minus 5 is transferred over to the other side?
So the question is, how did this become x cannot equal to 5? So anytime we're here,
Oh, no, sorry,
above.
yeah, that part right there. The x minus 5, the x minus 5 on the other side.
Yep, what about it?
Yeah, I'm just confused on how it goes on the other side.
Over here?
Yeah.
Because if I was to break this down here, right, this would be 3 times x, and this would be 3 times 5. So you see that the 3 is in common, yes? So that's why I have the 3 here. So now I only have the x minus 5 left, right? Okay. Because remember when we started doing that? Right? And our goal is always to make sure that this parentheses and this parentheses are the same, right? So you can use this as a guide. If I was to bring just this over and saying, okay, what do I need to pull out so that this would still be x minus 5? And if I distribute this back through, that gives me 3x. This times this still gives me negative 15. Okay? Any other questions? Nothing? Okay. Let's talk about simplifying. How many of you guys feel like their simplifying should just be this? Oops. Does anybody feel that way? It was positive 3. So this part is positive 3, right? It's when you solved for x here, you had to subtract 3 from both sides. That's why this is negative 3. Okay? Thank you for explaining that. That's awesome. All right. So if you think that reducing is this, that is wrong. I cannot reduce that because of the addition subtraction signs. Okay? I want you to think of addition subtraction signs being a family, right? It is frowned upon in the US of A to just go into someone's house and just eliminating people. I know. Darn US rules, right? So what should we do first? Go ahead. I got to do the AC method for that. And do the AC method for that. Go. You got to do the AC method for both. Now notice I put it off to the side, and then I'm going to bring it back in. Well, that's why we multiply together to see if it gives me negative 4, and then add it together to see if it gives us 3. That would kind of guide you in the right direction. Make sense? Yeah, absolutely. Love it. Just don't forget your x's in there. Like there and there. For these two, it's 4x and 1x. That's not right. But you didn't get what you got. That's wrong. Did we get that? Yeah? Questions?
Why do you do that extra step when you go to your conclusion of the investigation?
Right here?
The step ahead of the one before.
This one?
Yeah.
So we factor each one separately. So we got to find out what the GCF is here. And then we do this one by itself as well. What's the GCF here, which is 4. Cool. Any other questions? Go ahead.
Does it matter which side the x minus 1, x plus 4?
No. No, because, so the question is, does it matter if I put plus 4 then minus 1 versus minus 1 then plus 4? No, because they still add together to give you positive 3x. Okay? Now, here's the thing, guys. The reason why I'm doing some of these problems is because you should already recognize what the easy way is. What has been the coefficient of the trinomials that I've been giving you? What has been the coefficient of the x squared term of the trinomials that I've given you so far? So look at the last problem in the restriction. Look at that denominator. What's the coefficient of x squared? You can put your finger up if you need to. And then look at the coefficient of the top here. And look at the coefficient of the bottom. What has been the coefficient of x squared? 1. Okay? Everybody see it? Now, I want you to look at, when we did the AC method, your first step. What numbers did you get on the top? You got what? -1, +4, is that right? Do you see where the -1 ended up and where the +4 ended up? Look at the denominator. What were your 2 numbers that you got? -5, +4. Do you see your -5, +4? So in other words, the easy way only works when a equals 1. Only works when a is equal to 1. If you do step 1 in the AC method, you have your answers. Or you have your factors. Does that make sense? Okay? Now, I'm going to tell you that if you don't have the AC method down yet, you better get it down because some of these problems aren't going to have a equal to 1. So I'm wondering if we're doing it a different way on the exam, exam 2, did we screw up those problems when a wasn't equal to 1? Right? Does that make sense? Because, like I said to you guys before, if your friends, your family, tutor says, oh, there's an easier way, just do it this way. I told you to use that way, go back to that first example I ever gave you on trinomial and try it there. Because if it doesn't work, then it's not going to work for all. And the problem is that they don't tell you when you're supposed to use that easy method versus when you should not use that easy method. That's why the AC method needs to be down. Because you know I'm not going to give you everything that a is equal to 1. You know that. Okay? So, now, if I look at this, what are my restrictions? If I was to look at that and say, what are my restrictions? Go ahead. And? Try again. Close. X cannot be negative 4 and 5. Where am I looking for restrictions? Only the denominator. Right? That's why if you go back to the restrictions, I circled every single denominator or boxed. Right? It was always the denominator. So the restriction is all about denominators. Okay? Is there any factors that look the same in that fraction? Yes. Doesn't this one look the same as this one? So that's going to get canceled out. So my answer is going to be x minus 1 over x minus 5. So let's talk through this. When we did this problem, what was the first thing I did? What was step 1 here? And what did I do with them? So I factored top and bottom. You might want to write this down. Step 1, I factored top and bottom. Step 1, I factored top and bottom. What was step 2? And if you guys don't want to write it down, just mark down 5340. That's the part of the video that you want to go back to so that you hear this. What was step 2? Did I find restrictions? And then step 3, I simplified. Right? Step 1, factor top and bottom. Step 2, find restrictions. Step 3, simplified. So the question is, why do we find restrictions? Awesome. So I'm going to hammer on restrictions when it doesn't even matter. You're right, because right now restrictions don't matter. But I want you to practice it. Because when we get to equations, what do we usually solve for in an equation? X values, right? When we get there, I'm not going to talk about restrictions at all. And you're going to be like, wait a minute, I thought I had the right answer. Why is this the answer? And my reply is going to be, did you look at the restrictions? Right? So when if this was an equation and we solve for x and we got x equals negative 4, we have to reject that because this told me that x cannot equal to negative 4. If we get x equals to 5, we have to reject that because x cannot be can't be 5. Yes? Restriction. Yes. Yes. Right? It's kind of like, again, when you guys are in a relationship, right? There are restrictions. There's things that are going to trigger you that you're going to tell them, hey, these things trigger me. Do not do these things. How are you going to feel when they do those things? Violated. Make sense? Same thing. So if the answer shows up on those restrictions that you put down, then those can't be the answer. Make sense? There's so much about life and math, man. It's like, if you don't like math, you don't like life. Scary. All right? Any questions there? So 3 steps. Factor top and bottom, find restrictions, simplify. And this is for simplifying rational expressions. Okay? One more thing I want to talk about so that you guys understand the difference between this versus this. What are these two equal to? No. See, usually a fraction can't equal to 0 unless the numerator is equal to 0. Right? So whenever a fraction is equal to 0, that means the top has to equal to 0. So 0 divided by any number is 0. Other than that, a fraction can never be 0. The fraction will only be undefined if the denominator is 0. Okay? Those are only two things. Right? Other than that, it never is. If they were the same number, like 9 divided by 9, what was that equal to? Equals 1. Okay, equals 1. So one of these equals to 1. Which one is it? The one on the right is equal to 1. Because I can rewrite this as x plus 5. Because the x is positive, the 5 is positive, which is the same as this. So that's why those would cancel out, leaving you with 1. So the top and bottom are exactly the same. That's why they're equal to 1. But this one, are they the same? No. Because on the top, 5 is what? Negative, and the bottom of it? Positive. So the sign flipped. On the top, the x is, and on the bottom, x is negative. Again, the sign flipped. Everybody see that? So these two are not the same. They're actually opposite of each other, right? So I could look at this as in this way. I could say, okay, if I left the x minus 5, and I was to pull a GCF of negative 1 out of the bottom, I will actually have that. Or, you know what? Let me do it this way instead, so that you guys can actually see it. Everybody agree with that? Now, is that parentheses the same as the top? Look at the x on top. That's positive. The x on the bottom inside the parentheses is positive. The 5 is negative. The 5 in the parentheses is also negative. So those two are now the same. So really, I have 1 divided by negative 1. So what does that equal to? Negative 1. So that's the difference between those two. So if the signs are exactly opposite on top and bottom, negative 1. If the signs are all positive, they're the same exact terms or same exact factors, so therefore it's equal to 1 because they're same number. Okay? If you guys don't believe me, pick a number like 2. 2 plus 5 is 7. 5 plus 2 is 7. 7 divided by 7 is 1. 2 minus 5 is negative 3. 5 minus 3 is positive. 5 minus 2 is positive 3. Negative 3 divided by positive 3 is a negative 1. Okay? So you always use examples to get there as well. All right. So now let's talk about multiplying rational expressions. Let's keep it simple. Or do we want to? No, let's not keep it simple. Let's do that. What do you guys think we should do first? Ooh, factor tops and bottoms again, right? It seems like we're seeing a trend here that our first thing to do is factor top and bottoms. All right. Should I give you guys a second to factor all these? Go for it. Give you guys a chance here. Some say sub E. See how it go. People at home, when you get these four done, please just type in "done" in the chat. What's this first step in factoring? Ooh, maybe. And you guys in here, put your hand up. You were done. Yeah, yeah. Exactly. Yep. I should say this. If you have a question, raise your hand. If you are done, raise your hand with a thumbs up. Bless you. Gesundheit. Seems like a good time for me to use the restroom as well. Okay, I want to pause you guys right there. Just so you guys know, about 5 minutes has passed. About 5 minutes has passed. So just so you guys understand this, I want to put this in perspective for you guys in terms of how much practice we need. 5 minutes. Exam is 25 problems, is that correct? So we spend 5 minutes on every single problem. Guess what? That's 125 minutes. Your class is only 110 minutes. You're not going to finish the exam. Period. Is that fair? Look at it. And the question is, how much of this problem did you just get done? Did you factor all 4? And you're trying to finish? Or you factor 2 in the 5 minutes? So here it is. Done. No, it doesn't matter. Yep. The question was, can I write the x plus 2 times x plus 7, then x plus 1? Yeah, that's certainly fine. As long as the parentheses, inside the parentheses is the same, I'm good. Bottom right or bottom left? This one or this one? Both? Sure. Sure. Oops, that's not going to help me. All right, so if I took this one right here, first step in factoring is GCF. So I got to pull a 3 out, leave me at x squared minus 49. Okay? So this is the difference of 2 perfect squares. Oh. This right here also has a GCF, and the GCF is a 2. A times C is 7. B is 8. So my 2 numbers are okay? Any other questions? None? Are we sure? With what I just did? Did you just go straight AC method? Okay. Which is fine. So if you went straight AC method, so A times C is 28, B is equal to 16. So your 2 numbers were what? Huh? 7 and 7? That won't work. Okay. So you got 14 and positive 2. So then you got 2x squared plus 14x plus 2x plus 14. GCF is 2x, leaving you with an x plus 7. GCF is 2, leaving you with x plus 7. So you have x plus 7 and a 2x plus 2, but you realize that there is still a GCF. So you take out the 2, leaving you with x plus 1, and then the x plus 7. That's certainly fine. Just remember, so over here, the way I did this, and I was able to take the shortcut because this a was equal to 1. Where here, because the a wasn't equal to 1, I had to finish the AC method. That's all. That's the only difference. Cool? Any other questions? That was just step 1. What's step 2? Find restrictions. What are my restrictions? -7, -1, and 7. So again, I only care about the denominator, right? 3 is 3. I can't make that 3 a 0. I can make this a 0 if x was 7. I can make this a 0 if x was -7. I can make this a 0 if x was -1. I can make this a 0 by making x a -7. Make sense? How do I multiply? How do I multiply fractions, guys? So top times top, bottom times bottom. Ta-da. Very hard. Okay. So this is what I would do. I would say, okay, is there x minus 7 on the bottom? Yes. Is there an x plus 1 on the bottom? Yes. Is there x plus 7 on the bottom? Yes. Is there another x plus 7 on the bottom? Yes. So notice that I just went through the top straight up. The top has nothing left, so that gives me a 1. The bottom has 3 times 2, so that's a 6. So there's my answer. Yes. AC method. Getting enough practice on the AC method. This is why I kept on hammering about we need to practice, we need to practice, we need to practice, because it is this part that is going to be time consuming. When you're heeing and hawing, that's what burns time. Say that again? Yes, because there's nothing left, so there's always a 1 up there. Because remember, this divided by this is 1. This divided by this, this divided by this is 1. This divided by this is 1. This divided by this is 1. Right? So if you think about all of those are 1s, which is, when there's nothing left, there's a 1 on top. We okay? Do we need to go over the steps again? Step 1 was Factor top and bottom. Step 2 was? Find restrictions. Step 3? Wait a minute. Same 3 steps. What? Wow. Okay. Love it. Then let's talk about dividing. Yes? Almost the same process. There's going to be an interruption. Okay? So the 3 steps that you guys mentioned so far, which was factor top and bottom, find restrictions, simplify, there's going to be interruption between step 2 and 3. Okay? That's what's going to happen. There's going to be an interruption there. So we'll talk about why there is that interruption, and you guys should already know why there's an interruption. But yes, factor top and bottom. Should I try to give you guys less than 5 minutes this time? Let's throw on the timer. Where's my timer? There it is. Let's do 4 minutes. Because 4 times 25 is only 100 minutes, so you'll finish the exam. So go. Same thing. If you guys are done, thumbs up in class. At home, just type in the chat, done. And just remember, on the exam, you guys won't need to like show all the work, right? So that's where you're going to speed up a little bit more too, is that you won't need to show a lot more work than you guys would on the lab work. So that's what you got to be careful with. So once the factoring is done, let me know. We're down to 218. Half the time is gone already. And we done at home yet? Ooh. All right. Yeah, yeah, yeah. 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 All right. Good thing A was equal to 1, huh? Good thing A is equal to 1, huh? Anybody at home done? It almost seems like that they've turned my volume off. And they're just like, look, I'm just showing off my pretty face. That's time. Is that what we got? Yeah? What are my restrictions? Because that was step 2, right? -8 and 8. Awesome. So you get that from the denominator, yeah? So when you guys say simplify the last time, you meant to multiply, right? That's just part of simplify. So in dividing, how do we divide fractions? So what we need to do is something either called keep or I call it copy. Both means the same. Change and flip. Meaning I'm going to copy the first fraction or keep the first fraction. Change that division to multiplication. And then I'm going to flip this fraction here. But what do you notice happened when I flipped the fraction? Not yet. What do you notice when we flipped? We got a brand new denominator, don't we? That means we have more restrictions. Everybody see that? Because we flipped this fraction, this denominator became new to us. So that's why I was saying that between step 2 and step 3, that we have an interruption here, because when we copy, change, flip, or keep, change, flip, we get a brand new denominator, so we got to find more restrictions. Then we can simplify. Do I have an x minus 8 on the bottom? X plus 3? X plus 8? Another x plus 8? So my answer is going to be 1/3. As my Italian student would say, 1/3. Yes, 1/3. questions? So we're a lot quicker when a was equal to 1. So we need more practice on when a is not equal to 1. So in order to do that, however, the best thing to do is that I need you guys to just do the AC method. You already know the easy way. Right? The practice is about the AC method. So I would tell you, do the AC method on all these problems for now. This way, when you get to the exam, if the A is equal to 1, you got it. Right? I know that all of us want to practice on things that we're good at. All that is easy to us. The problem is that when it comes to game time, it's not about the easy things, because usually those are not there. So we want to practice on the things that we're not good at, which is getting the AC method down. Are there any questions here? Nothing? Yes? Yes. Yes. Exam 3 would be the week right before spring break. I'm doing that on purpose so that, a couple of things. Number one, I know that after spring break, your minds would be, your brains would be reset and you forgot math. Oh, it's only funny because it's true, right? Step 2, it's also right before the withdrawal date. So that this way you have 3 out of 5 total exams under your belt so that you can make a good decision of to stay or not to stay. Okay? So that's why. So if you guys are leaving for spring break a week early, maybe make some adjustments in your schedule based on what you need to do. Maybe you might have to take the exam before you leave. Okay? There is always that option. If you happen to skip exam 3, the final exam will replace that grade, but that means you had exam 1 already in the books, exam 2 already in the books, you'll make it for exam 4 and the final exam. However, if you decide to use that as a strategy of not getting the AC method down, I'm going to tell you this right now. Every single person, every single student in my past that has used this as a strategy also bombed exam 4. Just so you guys know. Okay? So, they will sit, literally, they will be like, I should have done exam 3, skipped exam 4. So some of them do say that. But again, if you decide to use it as a strategy, remember that you're also kind of closing yourself off of certain things. So God forbid something does happen, now you're in a pickle. Okay? Any other questions so far? Factor top and bottom. Set restrictions. Copy, change, flip. New restrictions. And then simplify. Correct. Yeah. Yeah. So the steps were find restrictions. So the same 3 steps that we had, right? The same 3 steps that we had. In between step 2 and step 3, which is where they added the 2 steps, was the copy, change, flip, and find more restrictions. I couldn't find 2 more fingers in there, sorry. So I guess I should have done this. It's going to be total 5. So it's factor top and bottom, find restrictions, keep, change, flip, find more restrictions, and then simplify. It's been there all along. The only difference is that you're the one that gave me their 5 steps. It was already there. It's like I already predicted. $5 years ago that you were going to give me those steps. Right? Because factor top and bottom, find restrictions, simplify. Factor top and bottom, find restrictions, simplify. Exactly the steps you guys gave me. Love it. Any other questions? Oh, go back to 135, 134, 45. All right. We're going to start into this. I know that we don't have much time left, but let's talk about adding and subtracting. And the reason why I'm starting this, even though we're not going to end it, is because I want to make sure we have enough time next class to cover the complex fractions. You guys are going to love complex fractions. Now, remember I brought up about the sisters, right? Because adding and subtracting fractions, what you guys need is common denominators, true? Well, the reason why I use sisters is because of this. All right? So, I'm going to jump right into an example right here. What do you think step 1 is going to be? Factor everything. Factor top and bottom. Awesome. And you're going to be like, well, we don't need to really factor top. We're right. In this case, we don't. Bottom is going to be what? X minus 2, x minus 4. This is going to be x minus 4, x plus 4. What do you think step 2 is going to be? Find restrictions. What are my restrictions? -4, 2, and 4. Beautiful. All right. How do I add and subtract fractions? What do I need? Same denominators, right? So, what is this denominator missing? Yeah, x plus 4. If I do that to the bottom, I have to do it to the top. Now, we might want to, when we see binomials, also put parentheses around those. And what is this denominator missing? X minus 2. If we do it at the bottom, we have to. It's as if you guys heard me say all those words before. Did I do this before too? Look at the denominator and going, is this denominator the same as this denominator? Did I do that as well before? Mm-hmm. Now, since this is not an equation, I have to keep the denominator. Meaning, when I rewrite this, the denominator has to be exactly is. x plus 4, x minus 2, x minus 4, and I'm going to rewrite the top. The reason why I want you to rewrite the top is because, depending on how organized you are, you might forget this negative. Heck, you might not see that negative. What do I have to do here? Double distribute. This has to be double distribute. Does everybody see what I got, how I got it? Do we know how I got the 2x and the 10? One x plus 4x is minus 3x. 4 plus 6 is okey-doke. Now, the next question you should be asking is, should we factor the top to see if anything cancels? Yes. But can we factor the top? Can we? What's A times C? What's B? Can we find two numbers multiplied together to give you 10, but added together to give you 2? So before we go, what was our steps? Factor, everything, restrictions. You could say simplify, but really, what did you find? You found common denominators, right? You could say find the sisters, and then you can say simplify. With simplifying, yes, you might have to double distribute. You might have to distribute, right? You might want to write those notes down going, you might need to double distribute. You might have to distribute. You might even have to factor to see if anything cancels, right? So that simplify is a really big umbrella there, right? So really, it's kind of 4 steps. You can even make it 5 steps because the simplifying is also adding, subtracting the top, keeping the bottom, because that is adding, subtracting fractions, right? All right? So, I'm going to leave you here and tell you to have a wonderful, blessed day. Please be safe. Love you guys. See you guys on Wednesday. Later. Yeah. Question 8 on the lab work? Sure. You will figure that out next class. That's what we're going to be talking about, 7 and 8 and 2 and 4. So 2, 4, 7, and 8 is going to be next class. Mm-hmm.